In this video, we're going to talk about gas furnace pressure switch testing. In order to test the pressure switches, we will need a manometer that measures in inches of water column, which is based on the old liquid-filled manometers that we all used to use. Today, they're being overtaken by the digital type manometers, but they still measure in inches of water column. Most of your pressure switches are the diaphragm type switch with normally open contacts. They have a diaphragm inside the switch which moves and closes the switch when pressure is applied by the inducer motor, which then sends 24 volts back to the ignition module that completes the ignition cycle. Notice that this pressure switch also has a snubber that is often used on pressure switches to regulate the amount of draft pulled through the switch. One purpose of the pressure switch is to make sure the proper draft is maintained in the heat exchanger by the inducer motor. If the heat exchanger or vent system becomes plugged or the inducer motor does not maintain the proper flow through the heat exchanger, the pressure switch will shut the furnace down. Another purpose the pressure switch serves is to monitor the condensate trap to make sure the condensate is flowing out of the furnace and not backing up into the collector box. If the condensate gets plugged, the pressure switch will shut the furnace down. In order to check the pressure that the inducer motor is pulling on the pressure switches, you will need to have a T to put your manometer in line with the pressure switch. On your gas furnaces where you have a single or a double pressure switch, you'll probably need just one T, but on some multi-stage furnaces and modulating furnaces, you'll need multiple T's to get properly tapped into the pressure system to check it with your manometer. Most manufacturers in their installation and service guides have diagrams like this that show you how to properly tap into the pressure switch system to check it with your manometer. A lot of furnaces out in the field have pressure switches that have inches of water column specifications on the switch itself. In these examples, you have one that is a 0.72 inches of water column, a 0.93 inches of water column, and a 1.40 inches of water column. This makes it really easy to troubleshoot these switches when the specifications for the switch is actually on the switch itself. However, there are a lot of switches that do not have the specifications directly on them, and so for that you would need to call tech support to get the proper inches of water column for that particular switch. In order to bypass a pressure switch, you must wait until the inducer motor gets up to speed and then connect your jumper wire across the terminals on the normally open switch to close it. We often do this to get the furnace running to make sure that our inducer is coming up to speed and we don't have problems with the heat exchanger. As you can see in this wiring diagram, the low pressure switch and the high pressure switch are in the 24 volt circuit, and they tie back into the ignition board, and they are normally open switches that must close once the inducer gets up to speed. During regular maintenance of a gas furnace, you should check the rubber hoses on the pressure switches for any cracks and make sure there is no condensate in the tube. A number of manufacturers have bulletins regarding the routing of the hoses or a change in the collection box ports to keep moisture out of the pressure switch tubing.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.